Hello everyone, this is just another short overview video of the scripting system. Before we begin to teach scripting, I thought it might be instructive to take a look at how the scripting operates, how the order of things loads, so that you get a more round understanding of how the system fits together. As the system starts up, it first loads system variables, global variables that you may have defined. It then loads our libraries from the library selections, and then after that it loads the screen interface scripts that you find in the scripter for the screen. And it is this order that you want to consider to be fairly important, because since the libraries load first, they cannot see screen interface objects. So you should not put routines inside libraries that try to talk to the screen, because they'll fail when they start up during their initialization quite often, because the screen is not yet created. This is just one of those chicken or egg problems that you'll always run into. However, in our case, it works fairly well, because you design your screen scripts in one section, which is the final section loaded, and your library scripts load about second or third in order, so all the other scripts in the system can take advantage of any library script. Okay, that's the first thing that you need to understand, and that's why you don't want to put any scripts into a library that talk to screen objects. You can create global variables inside a library, and then use in your screen scripts you could talk to those global variables. That should work fine. A couple things that we need to talk about are time. There's two types of time that go on here: linear time and parallel time. And to discuss that, let's look at it in the context of G-code. Here's a G-code program on the screen. And if I was to start execution on this line and hit the run button, you can see it begins to run, and we've executed one line, and we have one line in the queue that just disappeared to zero, but I'm sure you get the point. Every time we execute one of these lines, it is put into a linear queue, and this is what we call linear time, where every line is executed one after the other. Now, if we keep pushing run, we'll keep queuing up these lines. You can see over here on the right we have two lines queued up, one line queued up, and when it's finished we're down to zero. But now we're going to hit a script in the line. You can see here it's just a small script that does an engine rapid to 5:15:5. This also runs in linear time. When you tell it to run this script, you can see it just shot to that area. Nothing more will occur until that script is finished. So we call that linear time, where every line is one step in a gradual completion of the program, but it only goes one step at a time on a linear basis. But then you can also have parallel time, and this is where threads can run at the same time as other running threads. So let's take a look at a G-code program here to show you what I mean. Here's our spiral program. I'm going to rewind that, and now it's ready to go, and I'll hit run. And now the program is running, as we said before, one line at a time in linear space. Now let's switch to our script screen here. If we were to enter a script into this screen, and I'm just going to clear what I have on the screen here, we'll talk about that in a minute. Let's take a script. While one print hi there, and then yield. Now here's a script which, if I run it, would theoretically run forever. But every time it prints the words hi there, it's going to yield to the system and say, come back to me in the next time slice. And if I hit run on it, you can see here there's a DRO called parallel threads. We now have one thread running in parallel. So while the program runs, this thread is running. And it's not in linear time, because the G-code is still running at linear time. The script, if I hit a second time or a third time or a fourth time, we can queue up parallel threads. Now at the moment my log is filling up with hi there's, because we now have 7 threads calling hi there every 30 milliseconds or so. And you can see we're getting the print hi there. And if we look at the timestamp, they're approximately 32 milliseconds apart. So you can see that these parallel threads get a lot of time and they get to do a lot. Now I can stop the parallel threads with this new button down here called Stop Para. And when I do that, you see we went to 0 parallel threads. And if we look at our log, we can now see that we're getting lines, but we're no longer getting hi there printed. That's the concept of a parallel thread. And it's possible to write a thread and put it into the G-code stream and make it parallel with a thread command, which you don't have to know right now, but it would just be engine.goParallel. This would take a thread which was put into the G-code stream and throw it off to its side to run in real time and all the time. If you're wondering what such a thread would be used for, picture starting a thread in the G-code somewhere in your program, which starts up and runs all the time every 30 milliseconds, and it can check various inputs on the POKEYS board for maybe temperature of your spindle and adjust the feed rate of the operation. So you could run all kinds of parallel threads at the same time, checking conditions and then changing things. Alright, enough said for that. Let's stop that, and we want to talk about one more thing here. Okay, finally, the last thing I want to mention is that our FreeAxis have now changed from their previous function. I'm going to start a program because I think it's important that we have one running while we talk about this. So here's our program running the spiral. Normal program operation, nothing funny going on, but we can switch away from it to our script screen and show what happens with our FreeAxis. We have a second version of Tempest in the program, and this version of Tempest deals with our FreeAxis, the extra 4, in a mix and match way. You can set any of the 4 axes, and all 4 of them if you wish, to constant speed so that they'll run at whatever different speeds you wish to give them, conveyor belts and so on, for example. The axes which are not set to speed automatically become part of a second version of Tempest, which will do normal trajectory planning with them through script. So here, if we look at my script on the screen, you can see I'm setting axis 8 to speed mode, setting its speed to 200 units per minute, and then I set the feed rate to 1000, and then I just queue up 4 moves that basically cut a box with the Z moving in the box. If I hit run on this, you'll see the axes are moving in our box pattern. If I bring these forward so you can see them better. So while we're cutting our spiral pattern, at the same time, this second version of 4 axes is cutting a box. Now, this would not normally be used for cutting, and because of this, I don't store it in the continue processor, for example. I may at some point store it there. But at the moment, it's just used as something you would use for perhaps spindles as well as tool changers, because it gives you a 4 axes that you can manipulate in a trajectory planned fashion. One last thing I should mention about that is in these 4 axes, axis number 4 is always a rotary axis. So if you're going to use a spindle, this would be a good choice for spindle because it allows for full proper Cartesian coordinate on the other 3. But if you wish to use 2 as spindle, you should include 4 as one of them, and then any combination of the other 3 for your Cartesian axis. Okay, these are just things I wanted to point out about how scripters work, real-time threads, parallel threads, and the like, so that we'll have a basis of understanding of how scripts work before we begin to actually teach you how to manipulate the library to do what you need to do. So if you have any questions, join us on Augie's forum. We can talk about it there and discuss the way things work. Hopefully anybody who has questions on scripting will join us, and we'll all learn something along the way. Thanks. See you later.